Welcome back to Math Time with Mr. T. You already know how it is. We're finna go ahead and get this rolling. So today we're going to be focusing on two things: multiple populations and inferences. Basically, what these words mean is exactly what they say. I don't even know why I said that. But we have multiple populations. You know what the word multiple means. You know what the word population means. And we're going to work our way through each one of those things, like how we can use this data for ourselves or for another purpose. And then we'll move from multiple populations to making inferences about that information that we just gained. And you'll understand more as the lesson progresses. But like I said, let's go ahead and get this thing started. We have these different setups that we can go by. We have one population, two population, or multiple populations. Okay, so with one population, we're just taking the entire group, right? Whatever the population that we're talking about, we want everybody in that group, right? So, for example, an entire population would be everybody in your school. Everybody at your school has now become one giant population from whatever grade, kindergarten, if it's K through 12, from kindergarten to 12th grade, if it starts at 8th grade, kindergarten to 8th grade, that's everybody. We're going to take everybody in that population, right? And then we're going to find out whatever the question is about them. So if the question was, how many people at your school eat pancakes every morning? We're going to take every student who eats pancakes, and now we have our answer from the entire population. So we're asking a question of the whole population, okay? Now the next one is two populations, right? So now we have what happens is we're going to take one giant population and cut it in half. Okay, so my example, we're going to stick with the everybody in your school, right? But now we're going to say from K through 12, K through 8, wherever you stop, how many students are boys, how many students are girls? Now you have two different populations, and then you can ask the question, how many of the boys eat pancakes in the morning? How many of the girls eat pancakes in the morning? Now you have these different subsets that you have going on. You have your question and you have your answers, right? And you have your two populations. And the questions that we're going to be asking ourselves is, well, which population am I supposed to use? Well, that comes from you understanding what the question is asking you. And I'll get to an example for that, but let's go ahead and move into this last one for multiple populations. Basically what multiple populations is, once you're done with two, we're going to just start saying multiple. So if it was 3 up to 100, right? We're going to go ahead and just start saying multiple populations. So again, we can break up we can go back to your school, right? And let's say it is K through 8. And we only want to know the people from first, second, and third grade, right? So it's how many people in first, second, and third grade eat how many first grade, second grade, and third graders eat pancakes in the morning? Right now you have all your first graders who eat pancakes, all your second graders who eat pancakes, and all your third graders who eat pancakes. How many groups did you just make? 3. Or now you have multiple populations that you can kind of pick from. You can look at those numbers, and what I'm talking about inferences, and I'm gonna get more into that. But what I'm talking about with your inferences, though, like you can see, like if the third graders had 75% of their kids not eating pancakes or 25% eating it, in the first graders, I think I said third grade, second grade, third grade, whatever. You can say second grade and third grade, that'll be your 2. Second grade is at 25% eat pancakes, and then third grade is at like 35%. Your inference is, well, the third graders eat more pancakes, right? But we'll get more into that, or you can tell that third graders probably will eat more pancakes or eat more breakfast in the morning. So that is how basically multiple populations work, right? So here's our example, our actual example that we're going to deal with. You ask yourself, how many people in your school play sports? How many people in your school play sports? I'm not asking you the actual question, but what I do want to know is, how many populations will you have based on that question? How many students in your school play sports? I'm going to let you think about it, or you can pause the video right now. All right, you got your answer, great. If you said 1, good job. And one thing that I do want you to notice, when you are reading these word problems and getting through these questions, you just have to really just hunker down and pay attention to what you're reading. I said how many people in your school. I didn't say how many people in your school, your friend's school, your mama's school, all of these schools. I said one school. So just because you know that it is one school, one population, right? So that's how many people in your school play sports. Okay, that's easy. What about if I ask you, are the athletes taller than non-athletes? How many groups? That was silly. How many groups, man? How many populations will you have? I'm like pointing at the answer by accident. But I'll give you a second to think about it. How many are athletes taller than non-athletes? Go ahead and answer it. If you answered 2, fantastic, right? Because you have your athletes, and you're going to find out the average height of them, and then you have your non-athletes, and then you're going to find the average height of them. You have 2 groups that you're dealing with numbers for, right? In the last video, we found out how to find averages, and we found out how to find means and all of that good stuff. So there you have it, right? I hope that makes a lot of sense, but let's go ahead and do the last one for the multiple populations. It's the same thing as the pancakes. How many athletes are in each grade? Right? How many athletes are in each grade? Now, again, this is one of those times where you just have to listen to the question. How many athletes are in each grade? The key word in that question is each, right? Because now you can say, well, how many grades do I have in my school? Oh, well, I have K through 8, so that gives you 9 grades, right? So how many groups are you going to have? 9. You're going to find out all the kids in kindergarten, first all the way to 8th grade, who are athletes. Very simple. That's a multiple population. Okay? Let's go ahead and do one more example with the varying populations. We're going to do one more example so you can see exactly what I'm talking about, so we don't just say your school, right? So my question now is, how many people so if you've been stuck at home like most of us, and you've been watching TV like most of us, it's likely that you've seen these your vote or your counts or something like that, where they're asking you to count everybody in your family. Like my uncle counts, my grandma counts, my little brother who was just born counts. Okay, they're talking about the U.S. Census, and basically what they're doing is they're taking all the people in the United States and trying to find out how many of us there are, right? So now the question becomes, back to our example, how many people are in the United States? I'm not asking you about how many people are in the United States. I'm trying to figure out which one of these populations would we use. How many countries are we asking about? We're only asking about one country. So I ask you about one country. So it's only going to be one population, right? But what if I ask you, well, how many people are in each state? That's a different question, right? How many people are in each state? I'm not asking you how many people are in each state. I'm asking you again, which one of these methods will we use? At this point, now it's something on you to where you have to be able to understand. It's almost like another example that I had read. If it said continents, you have to know how many continents there are. That way you know which population you want to fall in. So when I ask you about every state, you have to know yourself how many states there are, right? So how many states are there? I hope you said 50. Fantastic, right? So, but at any rate, 50 is more than 1 and it's more than 2 by far. So we're going to be dealing with multiple populations, right? Lastly, we have 2 populations. Well, 2 populations. Of course, I'm going to tell you there's 2 populations. But if I were to ask you, who has more people in the state? Colorado or Nevada, right? Colorado or Nevada. Which, I'm not asking you to actually go out and count and find out. The question is about populations still, about these different populations. Which kind of population, which set of populations would we use? Will we use one population? Is that a one population question? Is that a multiple population question? Is that a 2 population question? I said 2 states, 2 population question. So if you have any questions or if you're confused by any of that, go ahead and send me that question down there. So now that we have the populations out of the way, let's look at something else. It's making inferences, right? So what I was trying to get y'all to understand was making an inference is basically just taking some information that you've gained and making a judgment on it, right? So, for example, if I gave everybody who's watching this video a ball of cheese or whatever, and half of y'all ate the cheese, I could be like, well, half of the people who watch math videos like cheese and half doesn't. That's my judgment that I'm making. I could be wrong. Maybe you just didn't want cheese at the time. But anyway, let's not get into that. That is like making an inference, right? So if we went back to our first example about the average height of a player, the average height of a player. Anyway, the average height of of these athletes in your school, right? If we go ahead and we're going to go with not just the people, but we're going to go 2 classes, right? The athletes and the non-athletes. And let's just say we averaged it out, right? And the heights were the same, right? So the average height of the athletes in your school is 5'6", and the average height of the non-athletes is 5'6". What can you say about height? What inference can you make about height in athletes? Well, in this case, there's no difference. My inference would be there's no difference between the people who play sports and the people who don't play sports at my school. Now, let's say the average height for the athletes was like 5'8", and the average height of non-athletes were 5'2". Now, my new inference would be like, if you're an athlete at our school, you're probably one of the taller people at our school, right? And that's basically me making an inference. You're probably one of the taller people at the school. Or if you looked at the taller person, and you know that information and you don't know the person, you'll see a person who's tall and you could probably make a judgment and say, that guy probably plays sports, right? He's probably an athlete. You know, it's just those judgments that you make based on data you already know, right? Now, when you take those 2 things, though, when you take a non-athlete and an athlete, and I'm still sticking with athletes, I'm sorry. If you take that athlete and that non-athlete, and you say, well, this is this and this is this, you are now comparing those 2 sets of people, those 2 populations. You're comparing those. And when you compare 2 sets of anything, it's called, and you make a judgment based on it, or an inference based on it, it's called a comparative inference, right? So it's just basically a comparative inference is just making a comparison of your 2 sets of data, right? So again, if you have any questions on that, please don't feel afraid to type it up and ask me, because I'm always willing to answer your questions. But make sure it's pertaining to this lesson that we're talking about today, or this lesson that we're talking about today. But unfortunately, our time has come to an end. Hopefully you're having a great day. Peace.